Hello, my name is Brian Berkowitz. I'm a professor at the Weizmann Institute of Science in Berkowitz, Israel, where I also serve as the head of the Department of Earth and Planetary Sciences. And an important piece of information about myself, I did my PhD work with Jacob Baer, who's sitting here beside me, back in 1982. I began working with him. I'm serving as the interviewer for this meeting. The objective is to prepare a time capsule at the initiative of InterPore, the International Society for Porous Media. The idea of the capsule is to hear from Jacob himself, his work over the years, mostly his work about the field of porous media, evaluating sort of what's been done until now and where we're heading for the future. We're sitting now in the offices at the Technion-Israel Institute of Technology in Haifa, in Israel. So please, Jacob, if you can start from the beginning.
I'll start by telling a few words about myself. I was born in Haifa, Israel, then Palestine in 1929. My parents immigrated to Israel from Russia and Poland. They were Zionists, and the idea was to establish a state for the Jews in this part of the world. I was first born. I have 3 sisters. I married my wife, Ziona, in 1951, and we have 3 children and 6 grandchildren. That's the brief history. After high school, I joined the Palmach, the underground army at that time. I fought the 48 War of Independence. After the war, I lived 1 year in a kibbutz, and then I started my studies in civil engineering at the Technion in 1949. I graduated with a BSc in 1953. After graduation, I started to work in a company called Water Planning for Israel, TAHAL. This was a national company entrusted with planning and developing water resources in Israel. It was then a national company. It's now a private company. It works mainly in Israel and abroad, mainly in developing countries. In 1955, I received a scholarship from the Dutch government, and I spent 1 year at the Rijksinstituut voor Drinkwatervoorziening. That's the government institute for water supply, working on and studying groundwater, the use of model for solving problems. My main interest was in 2 subjects for which the Dutch were famous. They have the knowledge of many, many years, seawater intrusion problems and artificial recharge. My supervisor at the Rijksinstituut was Professor Krull of Delft, and I met there an engineer by the name of Mr. Santing, an excellent engineer and a wonderful person. Returning from the Netherlands, I moved in Tahal to the groundwater hydrology department. You know that groundwater is a major source of water in Israel, and combined with the problem of droughts, which are very often in Israel, water is a scarce resource in Israel, and developing of water resources and managing of water resources and evaluating of water resources, and mainly groundwater, is a major subject. I worked mainly on one of the issues was seawater intrusion into the coastal aquifer and the relationship between the extent of seawater intrusion and the amount of pumping. Mm-hmm. I conducted pumping tests following TICE graphical solutions to determine storativity and transmissivity of aquifers. And with the information on storativity and transmissivity, I could write the aquifer equations, but we couldn't solve them at that time. One of my main tasks was also to determine the safe yield of the various aquifers. And we did it in a very simple way of taking the whole aquifer region or dividing the aquifer into a small number of segments and writing balances, inflow minus outflow plus rainfall or plus replenishment for the aquifer. And we tried to use the data on water levels to estimate the safe yield of the aquifers. Dealing with the seawater intrusion in the coastal aquifer, one of the 2 major aquifers in Israel, the mountain aquifer and the coastal aquifer, we use this sharp interface approximation. we developed solutions based on the Dupuy assumption and the Geiben-Herzberg, which is the same as the Dupuy assumption of mainly horizontal flow. And we came up with various solutions to the interface intrusion extent as related to the amount of water that goes into the sea, which is the replenishment minus the pumping.
So tell me, why did you stop your important work on groundwater and safe yields and water balances and then move halfway around the world or more with your wife and 2 young sons for a PhD in Berkeley?
I told you that my main work at that period in Tahal was seawater intrusion. And of course we used the sharp interface approximation. We didn't know any better. But we observed in wells that it's not a sharp interface, that there is a transition zone. Why is it? Diffusion. Diffusion is too small. It cannot, the transitional zone cannot be accounted for by the diffusion. I looked in the literature and I saw that in California, mainly in the Los Angeles area, they were dealing with the same problem. And they were also encountered it. And there was a group in Berkeley, headed by Professor Dave Todd, on miscible displacement, it was called at that time. He had students working on that subject. So I contacted him and I went to Berkeley to learn about seawater intrusion, not under the assumption of a sharp interface, but on the assumption of a transition zone. So I took my wife and 2 sons and went to Berkeley. I spent there 2 years working on miscible displacement or dispersion as we now call it. At that time, Dave Todd had also 2 other students, Rifai and Steve Lau, who were working on this subject. I looked at the literature and I saw actually 2 interesting research reports, one by Gerald de Josselin de Jong from the Netherlands and one by Safman from the UK on the theory of dispersion. So I started to work developing my ideas on Fickian type dispersion, the coefficient of dispersion, which is a second-rank tensor, the dispersivity, so the separation between the coefficient of dispersion and the dispersivity, which is a porous medium coefficient, which is a 4th-rank tensor. These were new ideas. I started to understand what causes dispersion, mainly the discrepancy between the Darcy-type velocity, the average velocity, and the real local velocity within the void space and parts of the void space at the macroscopic level, which is the true world, if you want, world of flow that carries the solute with it. And then I formed the whole model of dispersion in porous materials, the mass balance and the coefficients. And I returned to Israel. And after 2 years, and when I returned to Israel, I started to work on seawater intrusion, but this time with the ideas of dispersion. I want to add that in Berkeley, I had a chance to meet Professor de Jong, who wrote this paper that I mentioned before. He spent a sabbatical there at that time. I learned to love this person. He was a wonderful person, an outstanding scientist, an excellent painter, and an educator. And I would like to dedicate this time capsule to him, to Gerald de Josselin de Jong. When I was at Berkeley and doing the research, I understood that the importance of research to understand phenomena that I was working in the practice all the time. So I decided when I came back not to return to TAL as I was before working for TAL, I decided to move to academia and I joined the Faculty of Civil Engineering at the Technion, the Department of Water Resources and Hydrodynamics at the Technion. I didn't want completely to leave the practical application, so for 30 years, since 1960, I worked as a consultant to TAHAL and to the Hydrological Service. So I was deeply involved in working in the practice through my consultancy and through numerous projects that I was involved in, committees. So I kind of worked in two worlds, the practice I continued and the research at the Technion. Over the years, I was very lucky at the Technion. I had a number of excellent students, Gidon Dagan, Yehuda Bachmat, Brian Berkowitz, Karl Baester, Amitzur Barak. I learned a lot from these students. My last student, as you know, was Chunlin Chu, who is now a senior researcher at Lawrence Berkeley.
So you were still a member of the academic staff at the Technion, so you were doing the unavoidable administrative tasks as well.
Yes, at the Technion I had my load of administration from time to time. I served as Vice President for Academic Affairs for 6 years. I was Dean of the Graduate School for 3 years. I was Dean of the Faculty of Civil Engineering for 3 years. I was the first director, I established and was the first director of the Weizmann Institute, which is a policy research institute working at the interface between science and society, or science and engineering. So I did this as part of the life in academia, as you know. In 1997, I retired after 40 years at the Technion, because I started to work at the Technion part-time already when I was working at TAHAL before. So I count 40 years of my work at Technion. But I continue to come to my office every day doing my research, doing my writing, my work. I continue from time to time to teach mainly the short courses around the world. In fact, I think, and people think, that I am a good teacher and educator. Over the years, I developed mainly two courses at different levels, undergraduate and graduate: groundwater hydrology and advanced groundwater hydrology, and a course about the phenomena of transport in porous materials. And I developed 3 to 5 days of short course in transport in porous media and in groundwater hydrology, which I've been teaching all around the world. I also prepared the same subjects as 2 self-study distance learning courses, which I donated to InterPore, and if you're interested, you can find them free on the internet of InterPore.
I should add that when you were teaching these courses around the world, you were schlepping with you probably hundreds of transparencies. In that day, you didn't have the little disc on key, of course.
Yes, yes, I'm sure that I remember that I was carrying with me some 200 transparencies that we used at that time, and all kinds of similar devices.
So anyway, after retiring officially from the Technion then, you still continued with other administrative activities at that point?
Yes, in 2003 it was decided that by the Israeli Council for Higher Education to start a new school of engineering on the shore of the Lake Kinneret, some 70 kilometers east of Haifa, and I was asked to establish this school, to develop it. So I started in 2002 or 3 to establish this school. I planned the departments, I hired the academic staff, I wrote the bylaws, and I acted as dean for about 10 years, until about last of October. It took some time to build this school. The idea of the school was that it will be a lever for the social, economic, cultural development of this northern periphery of Israel.
So let's return to the early 1960s, where you were serving as a consultant to the major water authorities in parallel to your work at the Technion. Can you say something about the projects you were involved in then?
Yes, I continued to work on seawater intrusion, now without the restriction of a sharp interface, although we had the equation, but we didn't have the tools, which means numerical codes, to solve them, and it took some years to develop these codes. So partly we continued to work on the sharp interface approximation, but we knew more about the presence of the transition zone. And within the framework of this sharp interface approximation, for example, Gideon Dagan worked on his PhD under my supervision on upconing of the interface towards pumping wells. He used the method of small perturbations. I worked on management of aquifers, coastal and non-coastal aquifers. Here I would like to mention the work of the late Oded Levin, who developed the ideas of optimal management of aquifers, where in the management model, the equations of balance of aquifers served as constraints to the optimization model. I worked on the artificial recharge of aquifers through wells and through infiltration ponds. We have a problem with different kinds of water, and we needed artificial recharge in the phreatic coastal aquifer for storage purposes. There was no other large-scale storage in Israel. And I continue the work on evaluating the safe yield of the aquifers to estimate Israel's groundwater resources or general resources. As I told you, we wrote the aquifer equations, but we couldn't solve them, at least not in the mid-60s. And I built RC, resistant capacitor networks of hundreds of capacitors and resistances to solve the aquifer equation. Actually, towards the end of the 60s, we junked all this investment in Hilly-Shaw analogs and in RC network electric analogs, and we switched completely, of course, to computers.
Okay, so far what we've heard is your work in basic research and applied research in areas of groundwater hydrology. Can you focus now on the ideas and development of the more general area of flow and transport in porous media?
Porous media. When I started to work, I learned groundwater in civil engineering, and I started to work on groundwater. But after a short while, I looked at my desk and I saw the material on my desk, and I saw that I have the book by Muscat, the two books by Muscat, who was a reservoir engineer, the 46 and 49 books. I saw the book by Aravi Numerov from 53, Mal Collins, again 64, 61, Luton, Scheidegger, Luton in agriculture engineering. And I saw that they all actually doing the same thing. They speak in different languages, and I don't mean English, but they use different terminology, often different symbols, but they actually were doing the same thing. They were dealing with different applications of phenomena of transport, mainly flow, at that time in porous materials. And this led me to the idea that there is some common ground to all these applications, and that the theory underlying these applications is the same. And it goes beyond just Darcy law, because all of them were, of course, using Darcy law. And I gradually realized that they are all dealing with phenomena of transport of what? Of mass of fluids, of solutes dissolved in these fluids, one fluid or two fluids, and air and water in the unsaturated zone. Again, these are two fluids, and oil and water and gas in reservoirs, again, fluids, in that special domain called porous medium. So I started to look into the common ideas in all these applications, and I was looking for the common theory underlying it, and I understood that if I want to develop any theory, there was all kinds of equation and Darcy law, of course, and balance equations, but there was not a theory that starts from A, and I felt that the beginning must be the declaration of the porous medium domain and each of the fluids in the porous medium domain as a continuum. Darcy developed his law, but he never mentioned the word continuum because he was already thinking at the macroscopic level, and to understand phenomena, I felt that we have to develop the ideas from microscopic to macroscopic level, like fluid is coming from is the average behavior of the molecules, the transport phenomena in porous material is upper level to the microscopic level of what happens inside the void space. And this required the developing of the ideas around the REV, the famous graph and the plateau, and the size of the REV. So the whole idea of porous medium as a continuum, in fact, multi-level continuum, because you have at one level the solid, the level of the fluid, sometimes several levels of fluids, if you have oil and you have water and you have solute. And at each level, you look at the domain as and the transport as transport within a continuum. And the advantage of it was, of course, that you don't have to describe the interface boundaries, the fluid-solid interfaces, the fluid-fluid interfaces that you need if you work at the microscopic level. Kind of an advantage, and you have to pay for this advantage. And the payment is, of course, the creation of the various coefficients, the porosity, the permeability, the dispersivity. All these coefficients express at the macroscopic level the ignorance to the exact geometry of the interfaces between the phases. And the effect of these interface boundaries manifest themselves in at the macroscopic level in the form of coefficients. And that was the beginning of the theory of phenomena of transport in porous media, which now is common to many applications in groundwater, in reservoir engineering, in the agriculture engineering, in chemical engineering, and later in biomedical engineering, the human tissues, etc. So with these ideas, I started to work on the theory of phenomena of transport in porous media, started to work and to write, etc. Actually, I should make a comment here. I started by saying what led me to the need for a continuum was the fact that we cannot see and measure at the microscopic level. This fact is not true anymore because we can see and measure. You just look at what happened in the presentations at the InterPore meetings, and you see many papers and presentations on imaging. And with the power of computer nowadays, you can do it. Not in aquifers yet. For research purposes you can, but not in aquifers. So with these ideas, I wrote my first book, which was published in '72, on the dynamics of fluids in porous media. Actually, that was not the first book. In 1968, at the request of UNESCO, with co-authors Irmai and Zaslavsky, I published another book which dealt with a comprehensive approach to phenomena of transport in porous media. Later, in 1990, I wrote a book with Bahmat on an introduction to phenomena of transport in porous media. In 1967, I convinced IAHR to establish a section on porous media, and I served as its first chairperson of this section. In '68, I organized the first porous medium, transport in porous medium conference in Haifa, and the second one was in Guelph in '72. So this was not a conference on groundwater or a conference on reservoir engineering or a conference on ag engineering. It was a conference on phenomena of transport in porous media. And what was missing in this was a journal. So in 1968, I established the journal Transport in Porous Media, which first Reidel and then is still being published by Springer. I served for 25 years as its editor, and then I recently I transferred the leadership to the editorship to Martin Blunt of the UK, and he's doing an excellent work on it. And recently when I heard in about 2008, I heard from our friend Majid Hassanezadeh about his InterPore society. I was very, very happy because that really closed. We have the ideas, we have the conferences, we have the society, we have the journal, and I think that I made some contributions over the years to this new discipline, transport in porous media. I described mainly the continuum approach to porous media. You know that somewhere along the line we have the domain, we have the permeability, porosity, dispersivity, and then we have the models. But when you look at reality, you see the heterogeneity of these domains, and you know that you'll never be able to really describe this heterogeneity. And this led to other approaches, not the solving the continuum models, but to the stochastic hydrology. And I never worked in this direction, but this is a very important direction, and I envisage that it will be developed over the years again and again. So from Darcy law to a continuum and all the phenomena of transport described by well-posed mathematical models, and now we have the tools to solve these models. In 2006, I was invited as a Businex lecturer to Amsterdam to talk on the occasion of 150 years to Darcy's law. And I looked at the literature, and I looked at the conference that was in Dijon 100 years to Darcy's law in 1956. And I saw that in that conference there were many papers, most of them about applications. There were only two, Shraga Irmai and Deasselin de Jong, who presented really theoretical work. Nowadays, if you go to an InterPore conference or you look at transport in porous media, you see hundreds of researchers working in this exciting area, and that makes me rather happy.
So this is actually very fascinating, because many of the breakthrough concepts or ideas that didn't actually exist many years ago, people now just take for granted. So this is really quite fascinating, hearing the development of these ideas. Looking ahead then, how do you see the next steps of where people will be working or directions that the field is taking?
Of course, I was thinking about where do we go from here. In fact, each time I look at the TIPM issue or the agenda of InterPore conference, I see more and more people and more subjects. The more you learn, the more subjects are on the agenda. But still, I was thinking about a few directions. we have to, we can look under the microscope, now it's not under the microscope, to see what really happens inside the porous medium, to see exactly what happens in connection with the reactive transport and with the connection of multiphase flow and interface behavior and fluid-solid interactions. You know yourself, you are working in this area of non-Fickian solute transport, stochastic hydrology, non-Fickian solute transport. Of course, there will be more work on the ideas developed by BO on poroelasticity. I think there will be more work on non-Newtonian fluids, transport of nanoparticles and small particles and colloids with the flow in the void space. There'll be more work on fractured rock and the combination of fractured rock with the porous matrix. There will be more work on biological porous media, which is, it's not a porous medium. The idea of a porous medium is a multi-phase in which one phase is a solid and the others are fluids. In that sense, biological domains resemble a porous medium. It's not a porous medium in that sense that there is a solid, but there is a soft solid and fluids. And I can mention a few more subjects. I think we should know more on the dispersivity of anisotropic materials. We know very little about it. Actually, we don't know anything. How many coefficients do we have in the cases with the various symmetries? Dispersion in high rates of flow, heat dispersion, and capillary pressure under unsteady. I could continue to list subjects that are still on the agenda of researchers around the world. And thank you for this interesting interview.
Well, thank you very much. And I should point out also, we didn't mention before, for all of the work you've done, you've received numerous awards. There's a long list, covers a whole wall of awards. I think to me the most meaningful one is the Horton Award from the American Geophysical Union, which is really their top honor in the field of hydrology. So let me close just by recounting a story of a fellow, he's visiting a small town somewhere in the world, it doesn't matter where, and he sees an elderly gentleman there and he says, "Tell me, sir, do you live here?" And the man says, "Well, yes, I was born here." He says, "Oh, so you've lived here all your life?" So the elderly man says, "Well, not yet." So in that context, I'd say, I wish you also, have you spent your entire career in the field of porous media? The answer is not yet, and I wish you many more years of productivity and contribution and success and satisfaction.
Thank you, Brian.
Thank you.